All right, so let's move on to ED206, which is a more realistic heap overflow. The previous one had a pointer on the heap that you could overflow, and that makes it easy, but that's a little too easy. Here's a more realistic situation. So let's take a look at the source code, which is ED206.c. All right, and so here, here's how it was compiled, by the way. And here, you got a winner function and a main function here. And here you pivot two strings, string 1 and string 2. And so you allocate an object, and the objects you're creating are this structure, internet, which is just 3 pointers in a row. All right. I1, I2, and I3. Up here's the structure. There we are. So the internet structure has an integer followed by a pointer to a string. Fair enough. Okay. So an integer and a string, but it's just a pointer. And so now we're going to take, allocate the internet. We're going to set the priority of this. We're going to set the name equal to allocate 8. That'll be the pointer to a heap, 8 bytes on the heap. And here's another one. So it's going to have an integer and a string. And again, I'm going to copy the command line arguments into these two structures without restricting the length. So I only allocated room for 8 characters, so things longer than 8 characters will lead to overflows. And I should be able to exploit this, because when it goes out of scope and tries to delete these items on the heap, it will try to rewrite the pointer from one to the other, and that rewriting will use data from what I sent in. So I don't know exactly how it works, but the point is it will do a write operation, and some of the data I overrode will be in that write operation. This is what you really find with real heap overflows. So I can run this thing, ED206, and I can give it, say, AA, oops, got to have / 206, I can give it AA and BB, and there it goes. That's fine, but when I put in longer strings, that will cause it to crash. So up here I used, I'm going to fuzz it. You can fuzz it manually, so I can make this longer. And that doesn't crash, and I can try even longer. Oops, I hit some funny key. Oh, I see, I put in, all right, see, I'm getting this to stop fouling up there. I've got to get rid of that, okay. Okay, now it has a crash. So when the first one is really long, it crashes, and that means I can probably control something with those extra characters. So let's copy this here and do it in the debugger. Q, ED206. Okay, and run with those parameters. And so now it crashes. Now notice what's in the instruction pointer is 43, F6, and all this garbage. So the instruction pointer does not contain the data I put in directly. But if I do info registers and look, I can see EDX contains stuff I put in and EAX does. But anyway, it's not too obvious what happened there, but I can look at what code led to this. I can do x/2 instructions near the EIP. And let me get rid of the stupid colors. All right. There, so now I can see that it's going to move from EDX into AX. And EDX contains this 46, 46, 46, which is corrupted. So that's the pointer to that address. It's going to try to read from that address, which is going to cause a crash. And it's going to move into AX, which also looks like I can control that. AX is the lower 16 character. So it's AX. All right, contain GGGG, although when I did it, it doesn't contain GGGG, so that's a little disturbing, but we're close. Oh, I could only use the F's here and the G's there. Okay, so let me try running it with exactly the right input. So I'll be following my plan here, and then we'll see. All right. And you know, if you really understood exactly how it works, you might be able to figure out exactly why it is a write operation and what part is the data and what part is the address. But I don't encourage thinking that much. I never do. I would just do it by trial and error. Put in stuff and then use the debugger to see what happens. So now, when it crashes, I can do the look at the instructions and I can look at the registers. All right. And so this is going to move EAX into EDX, I think. I think it's going this way. And so EAX is 47, 47, 47, 47, which is G's, and EDX is F's. So now I know one of these 4 bytes is the address to write to, and the other 4 bytes is the data to write there. So now I can control an arbitrary write operation. So now I need to choose a write address. And so if I look at what's in main, disassemble main to see what's there, I can see what C libraries are used. Although I could just read the source code too in this case, but it doesn't really matter. So now I got to find where the buffer overflow is. And here's where I'm allocating the data on the stack. That was near the start. Here's where I do the string copy. That's where the buffer overflow is. So at this point, I have an opportunity to set up what will be an overwrite. And below that, I should find a puts. And there it is. There's a puts down here. There's another string copy and a puts. These are the 2 string copies that copy into the 2 areas. Here's a puts and here's an exit. So I could overwrite either the puts or the exit system call in order to gain control of the box. And what I'm going to do here is overwrite the exit. So I'm going to get out of here and look at the relocation records, which oddjump -R, and here I will find exit. There's the address of exit. That's usually what I want to do, is overwrite exit. Yep. And that's just what it was in my example, 4990C. Very handy. Okay, so now I just need to disassemble winner to find out what I want to put in there. So we go back in the debugger. Okay. And disassemble winner. And it's this address here, which I'll just put in the clipboard as we've done before. All right, and get out of there. And now we have to make an exploit file. So nano H11, and I'm going to put in the stuff from my clipboard here. That's the desired address. Now I'm going to put in this code from here. All right. All right. And it's the same as it was before. 0804 84AB winner. Okay, so this is going to do it. The F here is going to be the address of the exit function, which was 0804 990C. And the second parameter is going to be the address I want to put there. So this exploit file should do it. And I should be able to run it outside the debugger. So let's save it and make it executable. And run it to see how it looks. All right, it prints those letters and then it prints some unprintable characters, which is not bad. So now I should be able to run it ED206 and then take input from there. And I get a winner. Okay, so it works and then it crashes because I overrode the exit function. It wasn't able to actually do the exit. So it's the same as before. It's just a little not obvious how you get what's written and where it's written to. And like I say, I always just do that by trial and error. If you're real cool, you could like analyze exactly how every line works and maybe figure it out. But I just find the vulnerability and then get it working by trial and error. So that's the point. And again, there's a couple of remote, you can execute some of my remote servers here with the same logic. So good. And now all the flags are in the scoreboard, so it should be ready. Let me stop this recording.